Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on July 12, 2025, so just about 4 days ago. This paper shows that it's possible to use LLMs to automatically modify malware source code, reducing detection rates by antivirus engines by as much as 31%. The paper is titled LLMalMorph on the feasibility of generating variant malware using large language models. And the results highlight both the potential and the current limitations of LLMs in this cybersecurity context. The authors introduce a semi-automated framework to generate these variants from source code without needing resource-intensive fine-tuning. Alright, to put their work in context, this first table compares the LLMalMorph framework against previous research. You can see it's one of only a few approaches that works directly with source code. But what really makes it stand out is that it's the only method listed that uses an LLM and, critically, doesn't require any resource-intensive training or iteration. This combination of working with source code and using a pre-trained LLM without fine-tuning is what makes the approach so novel and, potentially, so accessible for generating these malware variants. So, this next figure breaks down how the LLMalMorph framework actually works. It's a two-part system. First, you have the function Mutator, which, as the name suggests, mutates or changes the code. It automatically extracts functions from the malware source file and feeds them to an LLM for rewriting. Then, the second part, the variant synthesizer, takes that modified function, merges it back into the project, and tries to compile it. And you can see that critical loop. If compilation fails, it requires a human to debug it before a final variant is produced. Moving to the results, these plots show just how effective this framework can be. We're looking at detection rates for 10 different malware samples, tested against 2 major analysis platforms. The top set of charts is for VirusTotal, a service that scans files with dozens of antivirus engines. The bottom set is for Hybrid Analysis, a similar tool. In each plot, the goal is to get the lines to go down, meaning fewer engines detect the malware. And you can see for many samples, like Xinfector and ransomware, the detection rates drop significantly. But while those detection drops are impressive, this next set of charts shows the other side of the story, the human effort required. Each of these radar plots represents a different malware sample. The axes show the 6 different code transformation strategies, like optimization, security, and specific Windows API changes. The larger the colored area, the more man-hours were needed to debug the LLM's output. You can see that optimization and Windows API changes, in particular, often required significant human intervention, underscoring that this is still a semi-automated, not fully autonomous process. So, to wrap things up, this research really demonstrates a double-edged sword. On one hand, the LLMalMorph framework is clearly effective at generating malware variants that can evade detection, sometimes reducing rates by over 30%. But on the other hand, it highlights the current limitations of LLMs. The process still requires a human in the loop for debugging, and there's a delicate trade-off between evasion and preserving the malware's original functionality, which was measured using a technique called the longest common subsequence to check if core behaviors remained intact. That's all for today's AI Research Roundup. Thanks for tuning in.